Hey man, you there? You there? Hey, I can't hear you. Can you hear me? Okay, I can't hear you.
Can you hear me, Dustin?
I can hear you now.
Okay. That's good.
Yeah, how's it going, man?
It's going. It's going good. I've just been
Good.
busy.
I hear you. I hear you. Busy.
Sorry, it's kind of cutting in and out here.
Totally fine. Totally fine. All right. So I'm just pulling up the quiz right now. See how what I was telling you about Thor's hammer? Really hot. Like the bottom of it was like too hot to touch. But I disconnected everything and I pulled the batteries out and charged them. They're only at 50%. Let it cool. The primary windings on the bottom, the smaller gauge wire, but they work just fine. So, you there? I cannot hear you if you are there. You have gone silent. Let's see here. Mm-hmm.
Hey, Dustin, can you hear me now?
I can hear you now.
Okay. Hallelujah. I tried using headphones, but I had to move into a different room. Yeah, I had to move into a different room.
Okay. No worries. Did you hear what I was telling you about Thor's hammer?
I did. I could hear you. I just couldn't say anything back.
Yeah. So it is very robust. No melting, no nothing. Handled 48 amps continuously for several hours.
That's good. Just got really hot.
Yeah, just got really hot, which we already not hot enough to start a fire. I mean, it wasn't. There's nothing burned on the inside. It was just hot. You know, it wasn't really hot.
Right. It didn't burn the diodes or anything, right?
No, they were cool. The diodes were cool, but yeah. So the diodes are cool. The batteries were a little warm, but it was from the transformer. The heat was the transformer. So, hey, hold on. Sorry, Ethan, speaking. Hold on.
A minute. What? I'm not going to be in it.
Okay, let's go take a bath, kid.
No.
Okay, buddy. Let's look at that.
I want to go in.
Yeah. Good question. I got there like, but we didn't. All we had to do was plug ours in. Put the board on. Put a little. And that was about it.
Started going up.
20 amps. LED display. Yeah, we have a power supply. I was using 20 amps LED display when it took 261. It was just a Neo picture. All in series. Nothing can pick up the 14. You could tell from like the first one to the last LED, the last one because of the amount of resistance. Really bright. Yeah, so it's just like on the back side and you don't have to worry about it. That's that. I had to go to the coffee shop physically. Yeah.
This place is armed with some of the most high-tech weaponry known to man. This is paper up, right, Father?
Hey, you there?
Yeah, are you still here?
Yeah. Sorry, I just gotta go clean up some vomit, and then I'll be back. Okay.
Okay. No, good luck.
Thank you. I'll need it. Because little tiny glasses, but it's really thirsty, and you had to turn up her. I need to wake you up, my love.
Guess so. No, I'm up to you for that here. was inside, went to die. I underestimated Brett before. It's not going to be easy. I think we can handle it. Oh, I Chihuahua. Oh, hi. Hello, Mother Ronald. I am you. I present you with me to confirm my engagement to the Doctor. What's going on? Oh, Miss Lucy Kumasi. You're engaged. What? Look, you seem like a very nice boy with a very nice face. Not engaged. Okay? Not happening. I understand. Don't believe I promise. I'll never forget you. Oh, I'm pretty sure I won't forget you either. Bye. Bye, Nico. Wow, that was crazy. Whoa, that was totally silly. Eating a bite of that cheese was the stupidest thing I've ever done. Right. It's over now. So, you have nothing different with what made you into another valuable thing and demanding all right, ladies, that's it. Nobody curses my daughter. You got that? You that's with me now. No. Now, yeah. Oh, I'm so proud.
Okay, I'm back. I'm sorry about that. You there? Josh? You there?
You can open up. Give him in medicine.
Hey, you there?
You ready, Dustin?
Yeah, I can hear you. I can hear you. Sorry about that. It's
Sorry.
DEFCON 5, puke everywhere.
Yeah, I hear you.
Or water sprinkler, blah, 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 blah.
Sorry.
That's all right. So, question 2. How far did you start on it, or?
Yeah, I'm on question 17.
Okay, so for question 2, let me just confirm with you. Variables are quantitative. Just the last one.
That's what I put.
And then for 3 students in an introductory statistics class at BYU, I understand. It is. I put B, an observational study, because they had no control over the price of the individual cereals.
I put A, but I could be wrong.
They had control over which cereals materials were selected, but they were observing the prices, not
Well, they were.
those prices.
Oh, I see. Yeah, that's correct. They're observing to decide. They're recording the name, size, and price, but they're observing the price. That makes sense.
Yeah, yeah. So for Math 221 project, one group of students studied the ages of students on campus. They collected the data from and 100 students. The sample mean was 2. Okay. What will happen to the sample median? The median will increase, right?
That's what I got. Yep.
Okay. Question 5. So for this one, it's
I got 66.5 for this one.
66.5. Could be wrong. Do what is it? 50 minutes.
Yeah, so it's 2 standard deviations away.
Yeah, so it should be 68%, right?
Well, that's 1 standard deviation. Remember, 68 is Z1,
Yeah.
95 is 2, 99.7 is 3, and then it's 10 minutes for each standard deviation, so that if it's 50 minutes, it's 2 standard deviations, so it's 95% of 70 minutes. Right? That's how I interpret it. I could be wrong. But
Yeah. I'm just trying to think because at 68%, it's the z-score is 1, right?
yeah.
The area of that curve, if you use the normal probability output based on what I have here, I just want to make sure. That would be this, right?
You're saying it's 1.58?
0.158 was the probability, but probability, the percentage would be 15.8, 15.9%. However, I feel like I'm missing a crucial part on that one.
Yeah. That one I wasn't exactly sure about.
And under 15 minutes, so 2 standard deviations away. So we're looking at -2.
Yeah.
And it'll be 2.28. Right?
So 2.28 completed the test under.
Because we're saying 68% of the data is in between z-score of 1 and 1. 95% is between z-score 2. So if you remaining 5, yeah, I think it's 2.28.
Let's go with it.
Approximately normal with a mean of 150.7 and standard deviations 10.2.
Connor?
13th percentile.
35th percentile.
Oh, sorry. Yeah, what did I say?
Did you get some breakfast?
So we're using the applet, right?
Well, that was what I was trying to figure out because they don't give you an N. So do you just take the mean? I did the mean minus the minimum minus the mean divided by standard deviation to get your z-score. but you're finding the 35th
Hmm.
percentile.
Yeah, give me just 1 second here. I'm trying to open up the descriptive stats. I don't want Q.
Says use the app.
Descriptive stats.
Connor,
Which,
which cereal do you want, buddy?
oh,
Or you want this one? This one?
hold on 1 second here. Let me look. I believe the mean would be 52, right?
0.7.
Oh, yeah, sorry. That's what I meant. Use the app, but I'm trying to figure out.
So do you have to use the applet find? So you put in the percentile in the applet and then put the z-score equal to get your n?
Um,
We're not finding the n. We're just trying to find.
so we're going to do 0.35. The first 35th percentile have a z-score of negative
0.385.
point. Yeah, so negative point.
By the way, I have to go to class and like.
Oh shoot! Yeah, okay. Record at all. Pretty sure.
Just see how far we can get in 13 minutes.
Pretty sure that this, because there's no collaboration on this one because it's a review. So. And so now that we have the z-score, we calculate the z-score. Let's see here. Have that as the z-score, and that is equal to what is the z-score equation?
It's the population mean minus the sample mean divided by the standard deviation divided by the square root of n.
Yeah, so
We're not trying to find n, where are we? We're trying to find n?
nope, we're not trying to find n. We're going to have some x minus the mean. The mean is 150.7 divided by the standard deviation, which was 10.2. So I get that as 146. So 35th percentile is 146 point. What's one decimal place? 0.8.
Sounds good.
7. Team of doing resistance.
I got right speed for that.
Okay. right skewed.
For 8, I got 2.236.
For this one, 2.236.
2.236, yeah. So you take 544, the 8550 minus the 8544 divided by 12, divided by the square root of 20. And I got 12.236, but you can enter that in your calculator real quickly.
Okay, I'll do it just real quick. But so we have the mean at
What? That one did? Me? Oh, there.
so you're gonna have 8550 minus the 8554. All of that is going to be divided by which was it? It was going to be 12 divided by the square root of how many gallons? 20 tanks. So I got negative 0.4907.
So you take 850 minus 8544 divided by 12 divided by the square root of 20.
So it's 8550.
Yep.
So 8550 minus 54
4. 2 4s.
divided by 8. Yeah, thank you. And then divided by
12. Divided by the square root of 20.
Nope, I got what you got. Yeah, we're good.
Okay, good. You had me worried there for a second. I was like, man, I've been doing this equation for the last semester. I hope I have memorized.
What is the probability the mean sample capacity of 50 randomly will be greater than? Okay, so we have probability random greater than. So we just do this.
I got 0.000.
So it should be 8540 minus all of that with the 50 randomly selected tanks, right? And you got what did you get for your Z-score?
I got 0.000 because it's the probability.
Oh, yeah, I'm just asking what you got for your Z-score.
I don't remember.
5. So you got 0.00 what?
Just 0.000.
I got 0.0092. 8540 minus 8544 divided by the square root of 50, right?
Isn't it the 8550 minus 8540?
No, it's the how much smaller it is. If it's smaller than the mean. If it's small, so since it's smaller than the mean, we expect a negative Z-score, 0.357. I plug that in, and into the applet, I got 0.0092.
Okay, I was off by a degree of magnitude.
Oh, you're good.
So you got 0.009?
Yeah, 0.009, yep.
So for 10,
so then which one?
Oh, go ahead. For 10, I got A.
Significance level of hypothesis test. It's actually B. It's the probability of committing a type 1 error.
Oh, sorry. That one is a p-value.
Huh. What's that?
Nothing.
Oh yeah, the one you had is for P value.
Yeah, I get that one mixed up. And then for 11, I got the first one.
Uh, I've got C.
But it's approximate. When you're dealing with the confidence interval, there can't be any type of chance. You have to be confident. So it says approximate or chance.
Okay. So then 12.
So for 11, I got just A.
Just
Did you get any others for A? For 11?
oh yeah.
You're kind of blipping out there, Dustin. What do you say?
Oh, I just said. Oh, you can pick multiple. I didn't realize that.
Yeah. It says mark all that apply.
The third year, you go back and work for them, just like as a thank you. For 4 years.
I think the last one applies.
But it's the true mean height of all adults in the United States. And it says it's somewhere in our confidence interval. But we only did
Yeah.
our sample from BYU, Idaho.
Right?
The population is United States. The sample is women at BYU, Idaho.
Right. But can you say from the sample of BYU, Idaho that all adult females in the United States are the true height from just that one sample?
Yes, because you have the confidence interval. The
Okay.
confidence interval is the one that
And I was gonna ask for like 70,
does that. So I think it's the last one.
like, you know, like,
So A and D,
3
A and E.
experience, whereas I got 0 experience.
Yeah.
They didn't offer it that much. I was just like, yeah,
Okay.
And I think also the second. No.
Okay.
no, you're good.
All right. So what'd you get for 12?
12. So I haven't read it yet. So marine biologists have been studying the effects of acidification in the oceans. The studies about use for this internet. Oh yeah. Okay. So
I've done it out in the hallway.
16 beluga whales.
There real quick. Real quick.
So I got B on that one.
You got B?
Yeah. Yes, because the distribution of sample means is normal because the data is normal.
Yeah.
Cool. And then 13, an investor with a stock portfolio worth $700,000. Okay. Okay, so we got to open up. What is it? Rates of return.
Yeah.
Did you do this one already?
Yeah, I'm on 17.
Okay.
Oh, yeah.
And
No, you're fine.
I'm getting an interview on it.
January. Yeah, that way it's December. Oh, I'm so excited.
okay, so let's see.
Now just you just brush up on it. I was just like,
Oh, I'm so excited for you.
I'm just like, I'll take it. It's just like.
Can you still hear me, Dustin?
Right?
Huh? Yes.
Can you still hear
I can
me?
still hear you.
Like,
Okay.
oh,
Okay, I
Yes.
put my headphones back in because it's getting kind of noisy in here.
awesome.
I can tell. And what is they want to ask? Collect a hypothesis test, right?
Oh, that's so much fun. No, that
Yeah,
would be
so
a good
13 it asks you to collect the p-value.
Yeah, so what they told me is I'm gonna be like,
Go to the
I got point.
inference.
Okay, so a little bit different.
a little bit different, but
So the S&P 500 is the mean return is 0.5.
Probably on top of that, you put
I got
So you got the-
0.019.
you'll get.
So okay, the confidence interval. What's the null hypothesis?
I put it as 0.95, the same as the confidence interval,
Yeah,
Why would you put it the same as the confidence interval?
because it says that the S&P has a known mean return of 0.95,
yeah,
and that's what you're comparing it to.
Oh, okay. How about that? So 0.95. I want to see if it's less than, right?
That's correct.
1.
Everything about their company and how they do training. They're gonna
So what did you get for your p-value?
I got a p-value of 1.
I did not get that. I got 0.019.
Show you what I got. See right here.
that's just
take a breather.
And it was 60. However,
Yeah, why is your end 60? It's not that many. You have some leftover junk there.
is that what it is?
Yeah, there's only 39 months that he invested, so you have something wonky with that.
Really? Okay. So I see that there's only 39. Oh, to be deleted there and do Control V here. Okay. And so then you got a p-value of 0.019.
Yeah,
That's what I got. Sorry about that.
No, you're good.
Okay, so 0.019. And financial economists studying married couples in which both spouses work must compare one mean income by husbands and income by the wives. Should dependent sampling. Yeah, so I put B on that one. Question 14.
You put B for 14? Yeah,
Yeah.
that's what I got. Uh-huh.
All right. So, you got to go right now.
No, you're good. I'll just skip.
Oh, okay. You don't need to, but
It's all right. He's just going to be talking
Okay.
about stuff that we've probably gone over anyways. Just about
Yeah.
answering questions. And we can talk to him tomorrow.
pressures of supply and demand act directly on the price of airline tickets. The seats available plane begin to fill. Airlines raise prices. What is the p-value for this test? Direct flight costs. We're going to close this. And so we're going to do a paired test. Right.
I did a 2-sample t-test. I didn't do paired.
Paired because you pick a flight and you've got to pick it for.
Yeah, but the price is independent of 90 days and 14 days.
It is, but each price is dependent upon the flight.
Sure, but the price itself isn't dependent on the day, which is what you're comparing.
I'm pretty sure it's a dependent sample t-test.
Could be.
Let's see. What test are we wanting?
Dad, did Mom ever end up showing you how to use that shampoo? No.
What is the p-value of this test? Okay. So no hypothesis not equal to, right?
Less than. You're comparing to see if it's less than 14 days.
No, it's different. she says a BYU Idaho student wanted to determine if there is a difference in the price of tickets listed in 90 days before the flight compared to 14 days before the same flight. It's the same flight, two prices, it will be dependent t-test, and since it's different, you're going to do the hypothesis tests are not equal.
No, this, I think this is it, because we know. Taking the circle.
So our null hypothesis is 0. So I got a p-value of 0.095.
So we would want, oh, it has to be.
Oh, sorry, 0.096.
I know.
And then. That's what we're expecting.
So what do you think about question 15?
If we're supposed to use unilateral here or bilateral? Because if it's bilateral.
Can you hear me, Dustin?
Yeah, I can hear you. Can you hear me?
Yeah, we.
Oh, you kind of blipped out there for a minute.
Oh, okay. What do you think about question 15? I got 0.096.
Yeah, go with it. I don't know. I can see how it's bold, but because I did it with a T sample
Mm-hmm.
and I got 0.4.
Oh, okay. And then question 15, if it was a 0.096, we would reject, would say no because the p-value was greater than the level.
Yeah.
So it's as soon as that way.
Okay. Question 17. Pretty good estimate. Hold on, let's receive this one. How many 10 homes? No. So I would say yes, C. The distribution of mean differences is normal because the data have been determined to be normal.
That's what I put.
Okay, cool. Hey, Dad, I'm going to put this away. I'm the one that got it out, so I was planning on it. Now, suppose the company of a hypothesis test to determine whether the estimates given by different can be the most appropriate pair of hypotheses for such a test. C on that one.
Why did you put C?
Where the null hypothesis is there's no difference, so the difference is equal to 0. But the alternative is the difference is not equal to 0, but there is a difference between the two appraisers.
Oh, yes. I put A. I said that they were equal and that they were not equal.
What's yours?
Yeah, and I can totally see how that would. But typically in these tests, they use mu difference or mu subscript d for difference.
Mm-hmm.
What's being tested is the differences. Right, but they want it in the differences, so. Okay, so suppose we create a 95% confidence suitable for mean. 2.
I had B for that.
Yeah. Yep. Okay. So this is the equations where we have 4 divided by 5 times.
And that should get us into the form of that one, right?
This is that NP is less than or greater than or equal to 10, correct?
Yeah.
So just take 4 divided by 5 times 10.
No, it would be 10 divided by 4 divided by 5.
So I got a half.
We don't have.
No, that doesn't make sense because you can't have a half sample size. It should be 10 over the fraction,
Let's back up.
not 10 over 4 over 5. So I got 12 and 50. And so the smallest size it could be is 50.
Sorry, I'm using like a punch calculator on my computer.
You're totally good.
So you got 50?
Yeah.
That's just something you just use about something. Use that one.
So you took, because it's n times p is less than, greater than or equal to 10, right? So you have to divide by the reciprocal, so it's 10 times 5/4.
Yeah, you could do it that way. Yeah, 10 times 5/4.
I got
So you get
12.5.
12.5.
Yeah.
You have to do the other test where it's 1 minus the p.
Oh yeah.
We don't have it.
1 minus 4.5, 1 divided by 5.
Well, 1/2 of this.
Yeah, so you're going to have 10 times 1 minus 5 times 4. That didn't work, sorry. Is 10 divided by 1 minus 4 divided by 5. You should get 50.
So you.
I got 9.2. 1 minus 5.
10 divided by 1 minus 4/5.
Yeah, I got 9.2.
Not the same.
I got 50.
Could be my punch calculator. Of
Yeah,
operation.
I got 50 if you can see that.
Oh, okay. I trust your TI-89 more than I do my punch calculator. Sorry.
All right. Your little brother. No, you're totally good. No worries. In the slightest. Your little brother has a career batting average of .233. You want to determine whether they'll probably have a batting average of times. So it's
There's no N over here. It's just there. Oh, N.
so it's .233 times
So that would just be. It would just be N.
40.
and say no.
And U. This is
Uh,
gonna be all multiplied.
that's the very last one.
Or 4 minus.
Because it's less than.
It's less than 10. Yep.
I'm your brother.
Oh, you're going to love this next problem, Dustin. Genetic takes a random sample of n equaling 140. Test portions which contain the chromosomes of development in the male. Some portions of dog and the male chromosome 46%. They have p hat 512, which is correct. Was interpretation of this statistic.
I can see.
So 52% of all gametes have the male chromosome.
Mayo zone. Yeah, C. That's what I put. Yep. Good.
Actually, would it be the last one? It would be 51.2% of the gametes
sample.
sample.
Yeah. I looked at that because it's not all dogs, just in a sample portion.
Yeah. So researchers published a study in which they considered the incidence among elderly. Calculate the probability that fewer than 320 out of. So it would be. And for that one, I got 0.427.
How did you calculate that?
320 divided by 750.
Okay.
I guess that's a proportion. Let me double check. So let me open this up. Categorical. Let's double check this. That could be wrong. I think what I calculated is just p hat, not the probability. One proportion. Okay, so we have x is 320, and this is 750. So that's what I have for p hat. And what type of test? So null hypothesis is what?
And with all their I'm just like
45%. So 0.45.
Yeah.
they can like start me like the end of
Okay. We do 0.45. And you want to see.
You take a picture of this. Oh my gosh. So, oh my gosh.
Fewer than, so you want to calculate that it's less than.
Yeah.
So then I get a p-value of 0.099.
That's what I got.
No, you told me this.
They got back in January. I mean,
We're going to do 1 point.
0.0911.
And it's, well, that's what I got.
Do tonight?
yeah.
Yep. Right? Okay. I'm sure that one.
So you got B.
Yeah, be on that one. Dog breeder. And you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It's known that the distribution of fertility levels of Cocker Spaniels is normal. How many measurements must you have in order to make sure the sample is normal?
Any sample size will do, right? I mean,
Yep.
any N will do. So the last one.
CRT. Yeah. CRT doesn't apply because it's already normal.
Yeah.
A study is planned to compare the proportions of men who just like I chose. So we're going to have 2 proportion tests.
And then we need to bring it into the time domain. But we have this C on top. So it's
Okay. So we have.
It's B.
Hold on. 41 times.
But
buddy?
Did you look up and you take care of Deefy? Deefy started to throw up in the towel. You looked up early.
I did wake up early. Yeah.
And Deefy looked up
So
me.
Can I talk to you a little bit later? I'm trying to do my homeworks. Okay.
What? I want to see this.
Here's the thing, when you work
Okay.
out, you get the exact same.
I say no.
You get the exact
The very last one,
Yeah.
right? Because you got 8.96. Okay.
Yeah. Mm-hmm.
She's saying
A study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate before giving the program. Each patient was a score based on his baseline.
Fitness.
Wait, but there's a Z on top. But the A's don't match. So
It
pull
would
out
be
and then use that one.
B. Yeah.
Yep.
which becomes it's X.
You don't know. You didn't do that one.
We kind of got stuck.
Weight Watchers wanted to predict how much weight client would lose if they followed a prescribed exercise program in addition to their diet program. Volunteers were divided into two groups. One group dieted, didn't exercise. The group dieted and exercised. The other group was linear. These linear regression percentile. Place in C with the program exercises. Lost pounds in 3 months as a responsible variable. One of the clients is told that his residual is 5.5 pounds. What does this mean? Now, remind me, what does residual mean? That's
Residual is the difference between the predicted and the actual.
That's right. Yeah.
Actually, we didn't go wrong.
So his predicted residual is
I think it's A.
yeah that his weight loss is higher than his actual weight, meaning that it was more to get that difference.
Yeah, let's see here. Let me just double check here.
Like it's not there, that means they're control people take it.
So it's the response. So it's what actually is minus the predicted. Okay. Let's see. What he did was lower. Okay, so his residual is 5 pounds. So that means his weight loss was 5.5 pounds higher than his predicted weight loss average.
Which is what we have.
Yeah, so it's B.
Oh, B. It's the other way around. His actual is higher than his predicted.
Yeah. B1 in the regression line was 5 pounds.
I feel like I'm taking the test, man.
I know. Let's pursue composers.
He done it.
You didn't throw up?
Yes.
I think it's C.
Okay.
This is 5 pounds. The percentage compliance goes up by 1% on average, and 5 pounds are lost in 3 months. Oh, yeah.
That's 5 pounds. So for every percentage
For every
of compliance.
Yeah, for every slope up. I agree with that.
Yeah. Okay. When creating a scatter plot, a residuals plot, and Q to Q plot, which of the 5 assumptions about linear regression are being checked? Check how to apply. I think it's B.
And D?
E. We have B to E.
B, D, E.
Yeah, I think it's those 3.
What?
Go get yourself a phone.
Okay.
What?
Red flat costs. And we're going to do.
We're going to do linear regression.
Just re-download this to be sure.
Wow.
So our coefficient is 0.780.
Hold up here. You're way ahead of me.
So is it the 90 day is dependent on the 14 day? And the 14 day is independent of the 19, so therefore the 90 day is the independent variable and the 14 day is the dependent variable? Or the 90 is dependent and the 14 is independent?
I'm not sure because the prices are independent of each other. The prices are dependent upon the number of days.
Right.
Does that make sense?
Yeah, I just said that they wanted to predict the prices of tickets 14 days before a flight based on the price listed 90 days before the same flight. What'd you get for your coefficient?
I haven't even plugged it in yet. I'm trying to understand that.
It's like this, if you times it.
You times them, I know they're adding.
Good news is we have 16 more problems.
Good news is.
Okay, so this is.
Don't leave that very cool.
So then that means you can evaluate this. Click and multiply it.
Okay, and so then we need to.
And how we
How do you switch rows in here? You just drag and switch.
so to get the -1,
I don't know if there's a switch row option.
we need to evaluate that.
Just have to copy and repaste.
And if we evaluate this by itself, like that.
More work.
Make this a 2.
I got the same coefficient for depend. It doesn't matter which way you put them in. They're the same. Correlation.
0.780.
Yeah.
So
Oh, Mandy Connor's bus is out here. Okay. Yeah, don't worry about it. Okay. So 0.
Drew, I'm just gonna take him to school. You can wait for us. What are you doing?
All right. So create a scatter plot using these two variables.
we apply this, but then we also have a shift.
Mom.
Fairly strong positive association.
Yeah, fairly strong positive association. Ah, that's cool.
K is your shift. So
Strong positive. Yep. So B on that one.
Subject.
Yeah, because you have 90 days. Yeah, you're exactly right here. Shoot.
I gotta relocate here, so my computer's dying.
Okay.
Give me a second. I'm in transit.
No worries.
I had to move because I couldn't really hear you in the other room, and some Emmys that were pretty noisy, but hopefully they're either done or not as noisy.
right? Okay, so I see a strong linear regression. I have the slope and y-intercept here, right?
Did you put the 14 days and then 90 days? Or did you put 90 days and 14 days?
I put 14 days as the response variable and 90 days as the explanatory variable. And so,
Okay, 90 as the x and 14 as the y.
yeah. Yep. And so for the next question, it wants to know what is the y-intercept?
I got 115.640.
Yeah, that's what I got. What is the slope? 7.
Yeah.
Predict the price of tickets for today's based on some costing $200.
So do you just put that price in the per x?
Yeah, so if we say 200 here, predicted it would be 240. That's cool.
240. Wouldn't you round up though to 241?
Place. So yeah.
What?
241.
Come here.
Is that what you put?
The slope. What's that? I
Did you
put.
put 241?
Yeah, I did. Yeah. And so for the slope, for the confidence interval, is the next question. I have 0.518. And the upper bound is
0.735.
yep. So that is 0.077.
0.07. Where is that at?
It's I just took the higher bound minus the lower bound divided by 2.
You see? I got 0.077.
Yep, that's what I got. The last one. Slope is equal to 0, and alternative is the slope is not equal to 0.
So you you got 0.077 margin of error,
Yeah.
and you took 0.3. Sorry, it's kind of hard to hear you.
No, you're good. What did you say?
Are you sure that's right though?
0.077?
735. Yeah.
Yeah.
Minus 0.518.
Yep. Divide by 2. Yep.
I get 0.185.
0.185.
0.085.
So 0.7.
0.1.
So 0.735 minus 0.518 equals 0.28.
You want toast?
And then divide that by 2. Weird. How did I? Oh yeah, I switched some of my digits around. Good catch. Yeah, so it should be
109.
0.109. Yeah.
Yeah. Okay.
Thank you. I switched the 8 and the 1 and the lower bound.
Oh, okay.
So 39 should be the very last one.
Yeah, that's what I got.
And then 40 should be 11.510.
11.510. Okay, yeah.
Yeah. And I have the p-value as 0.000.
Yeah, yeah. With those powers, it's got to be that.
Yeah. So there's sufficient. So C for 42. There's sufficient evidence to suggest that the slope of the true linear regression does not equal 0.
That's correct.
Okay, 43. In the United States, mothers who live in poverty generally have babies with lower birth weight than those who.
One sample T tests.
No.
Yeah, I think it's a one sample T test.
Trying to show?
9 volts over.
Yep, watch the game.
Equal to max gain.
That one now.
And we want.
What do you think for 44, man?
Well, I want to say it's a Z-test, but I think for Z-test you have to know if it's normal or not.
Yeah, Z-test means you have to know the true population standard deviation, which most times you don't know.
Yeah, but it gives us a standard deviation right here. It just doesn't give us the mean.
And input.
One sample Z-test. Let's do that.
Or is it a one proportion?
We're not doing that.
It's not a proportion because they're getting the measuring the vapor pressure.
That's true. It's just weird that it's both. Attorney wants to know whether the percent of Walmart employees know that are under 45 years old more than 30.
Test of one proportion.
Yeah.
8 millivolts.
Test of two proportions.
Yeah. That's what I got there. 47.
Jumps up to 6.
Yeah, don't worry about it.
Hmm.
Says they hope to show there's a linear relationship between the sales and the amount of money a client invests in radio advertising.
Linear regression.
All right, man.
All right, submit. Okay, so question 4 was wrong. Question 5 was wrong.
Suck.
Question 9 was wrong. Question 11 is partially wrong.
As compared to
My smart.
9 volts.
Question 24 was wrong.
And it said.
Question 44 was wrong.
So here's the thing, man. I know exactly why they're wrong, and I'm pretty good at a 91%. I don't know if I want to bother.
I got an 88%.
You got an 88?
Yeah.
So let's see, I got 47 right. I'll tell you what I got wrong.
I got 44 wrong.
I got 44 wrong.
Yeah.
Oh, I said 44 was a one sample Z test.
Oh, I said it was a T test. I thought you said two
That's
test.
the
Oh, man, I'm sorry.
more things that we
44. I got
24 I got wrong.
24. Yeah, I got 24 wrong as well. What it should be is
Point.
182. Yeah, what is it? Yeah, it wants to know for the alternative hypothesis.
Is it 8? Or is it, that's okay.
It's gonna be close enough.
So it's looking around 4,000.
Okay.
What'd you get on the multiple choice one for? Because I got 0.8. 8/10 of a point on question 11.
11.
I think the guy that
I got
was
0.4. I said it was A, B, and D, E.
guy who
A, B, and E.
Yeah.
Oh, I said C, D, and E.
And then he
C, D, E.
that extra one.
Mhm.
Come on, go get ready for school right now. You're gonna be late for school if you don't go.
C and C. I got 2 of them right.
Want to be get
Cool, man. Well, I don't want to retake it. Do you?
I probably will, but that's okay. I know you
Okay.
gotta get going.
Yeah, I've got to help Andy with Ethan's about to puke again. So yeah, I should probably head. So
Okay.
all right, man. Well, thanks, and I'll talk to you later.
Peace out.
All right, you too. Bye.
ready?